Hello there. In this video, I want to do a fourth video on my systems of linear equations videos, or my series of 3 system of linear equations videos. And the reason why I want to do another one is because in those videos, I showed you the same 3 examples, but they're all pretty basic examples. You know, when we're talking about the 3 methods, you could get 2 equations that are in slope-intercept form. You could get one that's in slope-intercept and one that's in standard form. Or you could get both in standard form. And then it's pretty straightforward because each of them have their strengths and weaknesses on which method you should choose. But what if neither of them, or at least one of them, is not written in either of those forms? What do we do? Well, in this video, I got 3 examples for you. I'm going to go over all of them, and I'm not going to go over all 3 methods. I'm just going to choose the best method for each example. So the first one, I have 1/3 y equals x plus 1, and then 3x minus 3y equals 2. So this second equation, I can see I've got it in standard form. This one is close to slope-intercept form. Now I could do a couple things. I can multiply both sides by 3, because I got the 1/3, and that would cancel the fraction out. Then I would get slope-intercept form. But I'm going to take a little bit slightly more exotic route, and what I'm going to do, 1/3 y equals x plus 1. I'm going to solve for x just by subtracting 1 from both sides. So I get 1/3 y, that cancels, minus 1 equals x. And then what I'm going to do is I'm going to use substitution here. So I'm going to take this, I'm going to plug it back into here. So off to the right here, I'm going to write 3x. Actually, no, I'm going to substitute in for x. So that will be this part right here. 3 times 1/3 y minus 1. Okay, and that's minus 3y equals 2 for the rest of it. Okay, so let's go ahead and distribute the 3. 3 times 1/3, that's 1, so I just get the y minus 3 minus 3y equals 2. Let's go ahead and add the constant to both sides. And since that's gone, I'm going to get y minus 3y, that's a negative 2y equals, and then I get 3 plus 2 is 5. And then we'll end it by dividing by negative 2, and I get y equals negative 5/2. Okay, so there's my y value. All right. Now, I can go ahead and plug this back into this equation because it's a little bit more simple to solve for it. So I get 1/3 times the y value of negative 5/2, and then minus 1, and that'll get me my x. So we got to add some fractions, but that's not a big deal because we're just multiplying here. 1 times negative 5 is negative 5. 3 times 2 is 6. And then on a minus, now I need a common denominator of 6, but since it's 1, that's simple. What fraction out of 6 gives me 1? Well, it'd be 6 out of 6. And so I get x, and then that means negative 5 minus 6. Well, that's the same as negative 5 plus negative 6. So x, I'll write it up here, is equal to negative 11 over 6, and we are done. All right, for the next one, I got 2 in standard form, but not quite in standard form because, remember, standard form, the x comes first. This one, the y comes first. Well, that's not a big deal. Let's just bring that down here and rewrite. I got negative 5x plus 2y equals 20. Now this is a little bit easier. We can just use elimination. Look for a variable. Now they both have the same coefficient with opposite signs. So when we add these together, this will cancel and this will cancel, but this will not. So I end up with 0 on the left side. 10 plus 20 is 30, which is not true. Those are not equal. This is an example of no solution. In my series of videos originally going over the 3 methods, we had one where we ended up with 0 equals 0, and that was infinitely many solutions. And I mentioned that if you get anything else, 0 equal to 30, or you could have gotten negative 2 equal to 5, or something weird, basically an equation that's not true, that's when you have no solution. That would be when the lines are parallel. Okay, let's talk about our last example. So here I've got a couple that are close to certain forms. Let's start with this first one. let's go ahead and multiply everything by 2 since we can get rid of the fraction then. So I'm going to start with 2 times 3, that's 6, then the x. 2 times 2 is negative 2, or sorry, negative 4, yikes. Negative 4, and then this will cancel with this. We just get 4, that should be y plus 3. And now we're very, very close. I think what I will do is I will subtract 3 from both sides. Cancels and cancel. Oh, no, sorry, not cancels, but simplifies. Minus 7 equals 4y. And I'll just do it in slope-intercept form. So we got 6x divided by 4. So this 6 divided by 4, well, that simplifies to 3 halves x. 7 over 4 doesn't simplify, and then we get y. Now this other one here, I'll go ahead and add 2x to both sides. We get 2y, this cancels, 5x plus 1, and then I will go ahead and divide by 2. And then I get y equals 5 halves x plus 1 half. So fractions galore. And what I think I'm going to use here is the substitution method, but really quickly I'm going to take some time to clean this up so that I can create more room for myself. 1. Okay, so we've got our equations. Let's go ahead. I said I was going to use the substitution method because we've got y alone by itself, which means we can basically just set them equal to each other. So 3 halves x minus 7/4 equals 5 halves x plus 1 half. And now we've got a slope-intercept equals slope-intercept form situation. So let's go ahead. I'm going to start by subtracting 3 halves x from both sides. This will cancel. And I'm just left with negative 7/4 on the left side. I get 5 halves minus 3 halves, fractions with a common denominator. That's great. So that's 2 halves, or just x. And I'm really starting to get excited because now the x is already 1. Or the coefficient is 1, pardon me. And we'll subtract 1 half. Now really quickly, negative 7/4 minus, we need something out of 4. So that would be 2/4. So negative 7 minus 2. Well, that's the same as negative 7 plus a negative 2. So up here, we get negative 9 over 4 equals x. Let's go ahead and plug that back in. I'm going to use this one because I can see it's got fourths in it. So y equals 3 halves times negative 9/4 minus 7 over 4. 3 times negative 9, that's negative 27, and then 2 times 4 is 8, minus 7 over 4. And then we'll make this actually, let's go ahead and give this a common denominator now. So fourths to eighths, let's multiply by 2, so this will be 14. We get negative 27 minus 14. That would be the same as negative 27 plus a negative 14. So that's a negative 41 over 8. And we are done. Go ahead and give a like if you enjoyed this video. Subscribe to the channel. And if you have any ideas for future videos, please leave them in the comment section below. And I will see you for the next video. Thanks for watching.